Extreme weather and greenhouse gas emissions by Aidan Harris, Noel Eifler, and Benjamin Carr. At first, these two topics may not seem very interconnected. However, they're very interwoven. The first example of how greenhouse gases have affected extreme weather is the El Nino of 2015. According to Live Science, El Nino is a weather pattern during which the Pacific Ocean warms, causing a change in the atmospheric currents above the Pacific Ocean. And in 2015, another weather phenomena occurred, the highest global mean temperature since the Industrial Revolution. According to Karen Northen of NASA, these two events prove the connection between greenhouse gases and extreme weather, because when greenhouse gases warm the atmosphere, in the case of El Nino, they cause greater amounts of evaporation, which caused even larger shifts in the winds above the Pacific Ocean. And this was linked to wildfires and droughts in the tropics of South America and Asia. So why do these changes occur? The changes in El Nino were also linked to atmospheric rivers above California, and because of the greater amounts of evaporation, more water was moved to California by atmospheric river, which caused massive floods in 2015. So why do these changes occur? First of all, according to Lisa Oko of the Environmental Defense Fund, when the atmosphere is warmer, more water evaporates, which gives more fuel to storms, and also the holding capacity of the atmosphere, as you can see in this graph, for water. The holding capacity of the atmosphere for water goes up, and this means that larger storms can form.
So we have three solutions, and our first and second solutions are actually very similar. Our first solution is a carbon tax presented by the World Bank, and a carbon tax basically sets a price per unit of carbon, and which means that there's no strict limit, and the companies get an economic benefit from reducing their carbon emissions. This also means that companies have time to meet the regulations and laws that have been set in place to reduce carbon emissions. But in order to keep a consistent increase in the lowering of carbon emissions, we would have to make sure to consistently increase the cost of carbon. And as this graph shows, it shows how much a carbon tax could reduce carbon emissions by up to 40% for some countries and raise GDP by up to 4%. One setback of this solution is that the cost of products may increase due to more expensive manufacturing, since almost everything that we make and use today has some correlation to carbon emissions. The second solution is to make thoughtful regulations that give economic benefits to citizens, and this one is by Colin Hines. So the U.S. did something similar to this during World War II, in which the U.S. implemented a bond system where citizens could buy bonds, and then the revenue from that bond system would be used to make all types of weapons and tools for war. We would edit this kind of system and make it more environmentally friendly, and we would have a little bit more steps, and we would take the revenue from the bond system, research and develop new products that reduce greenhouse gases, and then implement them in the form of regulations and laws. And then we take the revenue from perhaps a carbon tax or the reduced emissions, and we would give that back to the citizens that bought the bonds in the first place. And the citizens are given a little bit of money on top of that as an incentive to buy the bonds in the first place. And the only setback to this is that it requires citizen participation and government discipline.
So, a fantastic way to limit extreme weather is through the use of grid resilience. And the reason why, for those who don't know, grid resilience is where we shorten outages and reduce the damage of extreme weather on power outlines and stuff like that. The reason why this is important is because in a lot of developing countries, they do not have strong grid resilience, and because of this, they suffer and they lose tons of money from their power losses. So this all ties back to extreme weather because recently hurricanes and stuff like that came in and ruined power outages, and it's important for us to improve on grid resilience to do this. So the engineers have been designing different ways, and they've been using 3 main points, and that is prevention, recovery, and survivability. Prevention involves, first of all, standards, and then construction guidelines, better maintenance routines, and better inspection procedures so that it makes so that when extreme weather does occur, the damages are less effectual. Along with this, there's recovery, and recovery is where we have to go and we have to fix power outlines right after the extreme weather occurs. So the best part is to learn how to rapidly assess the damage. We also need to build mechanics and good crews to be able to assess in different cities. And lastly, gain better resources as replacement components. The last thing is survivability, which the main point is just to build communication with customers. With customers that are using electrical outlines, if they can tell what they need to the distribution companies, then they can make better improvements so that they can survive on points where power outages and the lights can stay on. The problem with this, though, is that it requires a new function for all the facilities, and with this new function, it can take a lot of work to switch every single one of them to this. So this hasn't been occurring very often, though it should. Now, there are many limitations to all of these, and they're all similar, but there's time and effort to set lines for metropolitan cities and improve grid resilience. It also costs a lot of money. So overall, though, it would be very useful if we were to improve grid resilience, though there are some small limitations.
So of the presented solutions, the most practical is putting a tax on carbon. This is because it has already been shown to work in some cases, and also there would be minimal cost to the government. This is also, or the reason that putting a tax on carbon is also the most practical solution is that improving grid resilience only mitigates the effects that extreme weather has on our society and does not actually mitigate our effect on extreme weather. So humanity has the power to shift our effect on extreme weather. We just need to implement the correct solutions in the correct manner. And here's our bibliography.